Hi, I'm Farhana and welcome to this lesson on trigonometry rules. Today we're going to be doing revision of our rules and specifically we're going to be focusing on exam type questions. So let's begin. Okay, just to revise our concept map, we've learnt all three rules and today we're going to be focusing on applications. Let's quickly revise our rules. The sine rule, can you remember what it is? Sine A over A equals to sine B over B, which equals to sine C over C. And we have the reciprocal version, which you should be quite familiar with. Okay, and when do you use the sine rule? You use the sine rule when you have one full pair and one half pair. So either angle side or side angle, but not the including angle. Okay. But remember, we've got to look for the ambiguous case of the sine rule. And remember, ambiguous case occurs when the set that's given, the full pair that's given, contains the smaller of the two sides. So because 6 is less than 10, it will be the ambiguous case. And remember, in this case, we can draw two different triangles with the same information. So this occurs when we have two sides at an angle. And like we said, that we have the shortest of the two sides given. Okay, our area rule, half AB sine C, half BC sine A, and half AC sine B. And you use the area rule when you have side, angle, side. Again, remember, we're looking for that V pattern. So a side, an included angle, and a side. When do you use the cosine rule? When you have two sides and an included angle. And again, remember, that's when you have that V pattern that we discussed earlier. Or you can use so these are the three formulas that you will use in this case. A squared is equal to B squared plus C squared minus 2BC cos A. And I think you're familiar with the other two. You can also use the cosine rule. Remember, when we have three sides, we just adjust the formula slightly to make cos A the subject of the formula. And then we can use this to find whichever angle we need to find if we are given three sides. So let's remind ourselves again, this is a revision. So which rule do we use? We start off by asking the question, is the triangle right angled? If it is, then we ask, does it involve angles? If it does involve angles, then we go right into our grade 10 trig. So we use our ratios to solve the triangle. We use sine, cos, and tan. If it doesn't involve angles, then we've got to use theorem of Pythagoras. Right, so this was grade 10 work. Now we get to the grade 11 work. So if the triangle is not right angled, then we've got to ask, do you have one full pair, that means an angle, and its matching side, the side across from it? If you do, then that's the green light for sine rule. Okay, so one full pair means we can use the sine rule. So we can either we have angle side or side angle. Remember, not the included angle. But if we don't have one full pair, then we've got to use a different rule. We've got to use cos rule. And again, cos rule, side angle side or side. Okay, so there was a quick recap of the rules. Let's get to our first example. Okay. Quadrilateral ABCD is drawn with AB and BC both equal to 10. So we've got an isosceles triangle there. And we're given AC is equal to 10 root 3. And they've given us the lengths of CD. And they've given us one angle, 74,47 degrees. Okay, and they want us first to calculate the value of B. So we're going to start with that question. They want us to calculate the size of B. So B lies in our triangle ABC. So we're probably going to be using this triangle here, ABC. And if you look again, we're given three sides in this triangle. And remember, when we have three sides, what does that remind us of? It means we can use the cos rule. Okay, so to calculate the size of B. Now remember, because we're going to be using cos rule, because we have side, we want to find B. Which means when we're writing an expression to find B, we need to start our equation with AC squared, with the side across from B. So we begin by writing it like this. We'll say AC squared equals. Now, we're going to use our V pattern, remember, to fill in the blanks. So AC squared is equal to 10 squared, that's that 10, and that 10 squared. Okay, and then we write both those sides in the bracket here, so it's 10 and 10 for representing both these sides. And because we've started off with AC, we have to end off with the cos of the angle across it, and the angle across AC is B, and remember that's what we're trying to find. We're trying to find AC. Sorry, just give me a second to erase. Okay, right, now we found AC squared. But remember, we're looking for B, so we've got to do a little bit of rearranging, okay? Okay, so we have, we've got to substitute AC squared, because that's the other known value we have. So we're going to substitute AC was 10 root 3, so we substitute that in. So AC squared is equal to 10 squared plus 10 squared to 10 times 10. Okay, let's just do some algebra quickly. Okay, so our algebra, we're going to bring this onto the right-hand side, so we end up with that, and then we just take this onto the right-hand side. Sorry, we brought the cos B onto the left-hand side, and we've taken this expression onto the left-hand side, right-hand side. Okay, sorry about that. Okay, and now we're just going to divide by that, because we're looking for cos B. We want to isolate the cos B, so we isolate the cos B, and we divide by 2 times 10. Put this answer into our calculator, and we're going to end up with cos of B equals to minus 0,5. Remember again that we are looking for B, so we've got to use our calculator, so we've got to take this 0,5, so we're going to say shift cos, and we've got minus 0,5, and we're going to find an answer, and the answer for B is now going to be 120. So B is equal to 120, and we've solved our problem. Okay, so the second question they ask us is ABCD a cyclic quad? So they want us to prove that ABCD is a cyclic quad. Okay, remember earlier we proved that B is equal to 120 degrees. So in order to prove that ABCD is a cyclic quad, in this case, if we can find the value of D and show that B plus D equals to 180 degrees, then we know that we've now proved that it's a cyclic quad, because this will mean that the opposite angles of the cyclic quad are supplementary. So we're going to begin by looking at triangle ACD and try and find the value of D. Now if we examine triangle ACD, we have one full pair, and we can work out D using this half pair here. So we're going to begin by saying sine of D over the side across it, and the side across that is 10 root of 3, is equal to sine of the angle, and the angle we are given here is this angle here, and we're going to use the side across it, and the side across it is 19,27. Okay, rearranging slightly so we can do the algebra. We're going to get 10 root 3 times sine 74,47 divided by our denominator. We're going to put this whole expression into the calculator, which is pretty simple. Your calculator will give you an answer of 0,866. Remember, you can't round off at this point. You've got to keep this answer in memory. And now because we're finding sine of D, we now need to use our shift sine value, shift on our calculator to find the value for D itself. And if we find D is 60, because remember that's what we're looking for, then we know we have a cyclic quad. Okay, so if you click shift sine D, we end up with D being roughly about 59,9, which is approximately 60 degrees if we round it off to the nearest decimal, which means now B plus D is equal to 180 degrees, and that means we've now proved that ABCD is a cyclic quad, because now we've just proved that the opposite angles are indeed supplementary. Okay, that brings us to the end of this session. We're going for a quick ad break. I'll see you after this.